Color Computer 3, Pop-Up Windows, Part B. Okay, if you remember from Part A, we did the overview of what we were going to do. Well, here we are. In this part here, we're going to look at the first two programs here, which is our basic program, which is the loader, and the stub program. We'll get through that, and then in the Part C, we'll do the main program, and so on and so forth. Okay, here's the basic program. This is all of it. Okay, it didn't very much, but this is loads everything up, hides everything in memory, so you'll be able to get to it and execute it with a pop-up window whenever you want one. A couple things here. We start with width 80. It could be width 40, just so it's a high-res text screen, either 40 or 80. And we'll do a CLS 100. Now, I don't know if you're familiar with CLS 100. We'll talk about it here in just a minute. And then we'll do a load in on the Stub program. It's a real sharp program, but right around 50 bytes or something like that. We're going to load it way up at high memory, up in the extended basic area, up in the F7 region. Okay, there's a little bit of room up there. We can hide that program up there. Then we do a load in on I call it pop load. It's the main code. It's in two parts. The low part down E00, and the other part is up a little bit higher. And we'll execute the lower part, and it will set up all the parameters we need and hide the main program code. So it's all this stuff is available at any time and won't interfere with anything else, and it'll be hidden. Oops. We're going to poke a 0 in EO47 and EO3. And all we do is make our screen look good. That gives us black borders. Our attribute is 60, which is white on black. So the screen will look like what we're looking at here. And we'll print out some stuff. So yeah, we got the things loaded, and load your test program and give it a shot. Okay, the stub program. I had a few things I needed to do, find out a place where to hide it, so it'd be up there available at any time. The other thing is I have pop-up windows, as I showed you in Part A. I have pop-up windows in mine, and I had to work around my pop-up code because I didn't want to break mine to do this new one. So I didn't want the new one to interfere with me, and I didn't want mine to interfere with the new one. So anyway, I found a place, so settled. The size of the stub program is a hex 34, 52 bytes. It's keyed to this thing, but it does everything we need to. Unraveled code error. Okay, it's not really a code error. It's a decode error. The notes and the person that did the unravel document has a few errors in there that I found. So, and I'll go over that with a little bit when we're looking for a place to hide our code. Accessibility. Put some new parameters in our include program, a common include, where we can have a common entry where we get to it from any program you want, just some jump subroutines. Okay, here's the one that you've probably seen 100 times, maybe too many times. Remember, this is the MMU task 0. We're going to stay in task 0. We won't be doing any task 1. So again, 0 to 64K. Common stuff, FFA 0, 1, 2, 3, 4, 7, which is task 0. And when you load it in, you got hex 38, 39, 3A, B, C, F in there. We're going to be working with these two highlighted ones here. We'll be bringing in the high-res text screen / pop-up code, which we'll talk about here next. And a work area. I called it pop page. It could be called temp page or work page. I just give it a name for this exercise. One's at the hex 36 page. The other one's is hex 10. Well, let's look at this block 36, which is the high-res test screen. We worked originally back in lessons 1, 2, and 3. Somewhere back in we worked with the high-res text screen. This is the same thing. We'll bring that block in 36 in the FFA1. Which will go from 2000 to 3 FFF. Now, the high-res text screen only consumes the lower half of that block. Okay, so why do we know that? Because the high-res text screen, the most we can have is 80 characters wide and 24 lines. So 80 times 24 is 1920. And if you remember, every character also has an attribute byte. So we take that 1920 and we double it, and it comes out to F00. Okay, that's it. It doesn't even quite fill up this lower half of this here. It's like 256 bytes short of filling up this lower half. And from 3000 to 3FF is open to hide anything you want in there. So we're going to put our pop-up code in there, and whenever we bring the text screen in, our pop-up code is going to be sitting right there waiting for us. Okay, the pop-up code will be loaded in at 3200. So when the stub program brings this block in, he'll do a jump routine to 3200 and execute the code. And you probably ask the question, why is 3200? Why not at 3000? Good question. I told you I had my pop-up code was in the system, and it's loaded at 3000 to 31XX, so I just stuck this at 32. If you're compiling this, you can change it down to 3000 or wherever you want it. You can go up higher. Any place you want it, it's just that's why it's at 32 and not 3000. Okay, so that's kind of an explanation. Now let's back up here some to there. Width 80, CLS 100. I don't know if you're familiar or not with CLS 100, but if you do a CLS 100, let me bring up, I got VCC running here, just like I just booted it, and I'll do a width 80, and I'll do a CLS 100, and that will give us the names of the two authors of the code, the high resolution, extended, super basic, whichever you want to call it. That's the two people that actually did the code. Now, if you type in CLS 100 again, it will give you Microware Systems Corp. is the company that did the code. So every time you do that CLS 100 in the future, it will give you the microware name. Why do we care about that? Because we're going to get back to my other screen. Once we do that, we want to load our code up in that area. So there's so many screens here. And find it. Let's look at the unraveled. Why do we do that? Okay. I snipped this out of the unraveled code, just a hunk of it here. And if you do a CLS 100, you just turn your system on, and you come down through this code, and you see here, this compare B to 100. That's checking for, move this over just a little bit. It's looking for that CLS 100. And in the notes it says if it is, then print the author's names, which it did. So it says branch equal to F730. Go down here to F730. Okay, it does a branch subroutine, and it does the same thing we did. It's going to bring that high-res text screen into FFA1 or address 2000, same thing as we do. It's going to clear that text screen, and then it's going to put that block back out. It's going to take it back out. It's going to bring the block in, clear it, and take it back out, just like we do. Then it's going to point to the author's message. That's what that stands for. And right there, I don't use this editor much, but it highlights it. So there's a minus sign there. Anyway, points to the author's message and jumps to a routine, and up there it's called print something on the console. So it prints it on the console, that author's name, comes back, it pushes X, and then it loads up an address F6, F4, and some no-op. So let's look at F6, F4. Go back up here, and F6, F4 is right here. This branch equal that we took before, them 2 bytes right there. So it comes in, it's going to put no ops in them two positions. Okay, you see that? It does a stored X. See, there's a plus again. So it's stored in 1 byte and the next byte. So them 2 bytes now are node ops. Again, if we look at that, so if we're coming down through this code, we can compare it to 100. it doesn't have a chance to take the branch because it's been no op, so it just always falls through. The fall through is always load up the name of the microware message and print it on the screen. Same thing as the other code. If you look down there, it's the same thing. So he's no op them 2 bytes. Then he's going to load up the address of the author's message, okay, and start storing no ops in that, and just keep going through this routine here, looking for the address F74D, which is right here. So it just loops and it clears out all this stuff from the author's name here at FF1B all the way down through right there. So when it clears out this CE with a no op, the next thing is compare it to F74D. It does not go any farther because it can't, because it'd be overlaid its own code. So it just falls through and returns. So everything above here has no ops in it, which is available to use. Okay, so that this you can't get to this code here, so it really is available from this F756 up to 1B. So where's the disassembled wrong code? And I also put my notes in the middle of this. The first time CLS will print the authors to screen and then change the above 2 bytes to no ops and no ops from 1B to 4C. Then you can use 1B to 5.6 or 59 bytes. And if you recollect, when we looked at the stub program, it was only like 52 bytes long. So there's a place we can put it. Here's where the problem, not problem, but here's what's wrong. You see this here, it says microware commercial or their message. Well, if you look in here, he's got the names of the authors in there, and down here in the author's message, hex zeros. And it's confusing when you're looking at the code the first time till you figure it out. Here's what the code should look like. Microsoft message, microware systems carp, carries return, null byte, authors, and okay, so that's what it should like. That's just wrong. I mean, it's all, these are all in the same place. So anyway, that's how we come up with the place to 59 bytes so we could hide it. Once you go through new CLS 100, that is available, so we're hiding our stub program in there. Careful, that was a lot of something. Oops, wrong screen again. Got too many screens here. Let's look at the code finally. Here's our stub code. Kind of some of the same things here. We don't want to print out the common list, and we don't want to print out the macros. Now, in the common include, I put a version number. I had too many common.includes for these classes, so this one here I put a note inside of it. This is the PopUp version. It's backwards compatible, but I needed to know forward where the heck am I at? I had like 5 or 6 comments. Anyway, and we really didn't need the macro because there's no macros in there, but you can leave it in. All right, here's the code. Now, if you just remember, look what we just looked at in the unravel thing. F71B was the first address we could put code. So we're going to start right here at F71B, and here's our pop-up code. Okay, here it says pop in. We'll talk about pop in the next part D. Okay, there's a pop up and a pop in. Okay, we'll discuss it later. Anyway, and here all we're doing is if it's a pop in, we put an AA in there and store it and save 5. Okay, well, let's back up before we get lost here. Let's look at this common include so you know what we're talking about here. Okay, this one here has the version description at the top. And we'll come down here and see what actually got changed. There we go. I added this here and there to do the pop in. That's where the address of the code is. So you do an indirect jump to this address, and we'll talk about that a little later. To get to the pop-up code, an indirect jump to this address here to get to the pop-in code. And use these 10 bytes. Save 1, save 2, 3, 4, and 5. They're all hex zeros. Be careful. And I have this in my code because I have a lot of programs, a lot of routines that use this here. If you want to store something and you don't want to use a stack because you get 2 or 3, enter return or jump subroutine. When you get too deep, you just want to have an address to store it without keep defining stuff. But I put there temp for this program routine only. So nothing is guaranteed. You're on your own. Anyways, right? This is a place to use for switches or whatever. And the memory page, I called it pop page. Page hex 10, temp storage. You could probably call it temp page or work page because I just called it pop for this exercise. And I res 36. That's all the changes. Okay, so now in the stub program, it's going to come in and load up A and store A and save 5. Okay, if you come into the pop-up routine, it's just going to clear save 5, so the main code will know what's it doing. Pop-up will return one character back to the caller. Pop-in will return the string, the input string that's put in. That's the difference. Okay, the entry into either one of them is a pointer to the pop-up table. We'll get to that in the next 1 or 2 lessons. Okay, that's actually says what do you want to put on the screen, and what's the attribute for the stuff you want to put on the screen. So the first thing it does is pop up. Once it gets here from the stub program at 3200, because that's where we're. I'm sorry, this is the stub program. I'm getting ahead of myself. It's going to bring in the block. I'm going to save the parameters, bring in FFA1, save what's there now, load up the high res, which is our hex 36, store it in FFA1, pull up the parameters, and jump subroutine to 3200. That's where our code's at. So we come in, we got the parameters, the X and B, we pushed them, we pulled them, and we're going to 3200. 3200 is going to do whatever it wants to, whatever you're telling it to do. It's going to pop on the screen and come back. It's going to return sub back to this program after it's done its job and clear everything. It's going back to this program. This program will load up FFA1, load up B with what we stored up here. Stored it somewhere, stored it here. What was originally on that block, store it back in there, and return back. Okay, so this is the stub. The stub is coming back to you. Everything back is exact as you would call it. It returns back the same way. Down here is that save 1, 2, 3, 4, 5, and we got 2 other things in here. At FF49, it's got the address of where the pop-up and the pop-in is. Okay, so I'm jumping around here pretty quick, but remember in our common we had pop-up was located at F749, and F749 is the address of where the pop-up is. So when you do a indirect jump to FF49, it's going to take you to F723, which you can see up here is our pop-up code. Confusing? That's the best way to keep everything clean and where you can change anything in here you want. You add stuff, not add stuff, whatever. And these here will always be guaranteed if you do it this way and have it in your comments. So, and here's them 5 bytes. Okay, so much for the code. I think we're done. You're looking at my notes. Yeah, I think we're done. That's all. We're just going to do the basic program and the stub. I hope we got too confusing. Go back to this 1 or 2 times and might understand it. It's to get everything hidden in the system where you can address it any time. If you got a number of programs, can use this, and in the future ones, with some additional coding, you can also do it from basic. It's not too glorified in basic, but then again, it will work. So until then, let's part C, which will be next time. We'll talk about the main guts of the actual pop-up of what we're going to do with that. So until then, I'm going to say we are kind of done with this exercise again. So hopefully this helps. Hopefully I didn't forget anything. So goodbye.